Hi guys, nice to see you back. Today we're going to clarify a lot of confusion around the 7-segment displays. You should love this one because you're going to find this confusing information in a lot of magazines, in books, and everywhere else. And the reason for that is the manufacturers have too many models of 7-segment displays. Let's go. In order to clarify that confusion, we're going to focus on one model, and only after we finish with this model, we're going to pass to another one. So this is a 7-segment display whose size from here to here is 0.56 inches. Okay. This is an original model, this one, now made by Ohm Semiconductor, is the former division of the Motorola. So MAN 6760. This is a Chinese copy. As you can see, the code is completely different, but you can just Google 5161 model and you're going to get it anyway. So they look alike, okay? 0.56 inches size. We're going to need 3 paper sheets, 1, 2, and 3. And of course, I'm going to put them in the description of the video so you can download them all. Okay? So we started. If you take a look from the top of any 7-segment display, this is where the name comes from, because you count the number of segments, and as we already discussed it, if you count 1, 2, 3, 4, 5, 6, 7, and with the decimal point, 8 of them. The only thing the manufacturers respect regarding the appearance of these displays is the order of the segments. So here, if we take a look, this is what the manufacturers respect. You take a look from the top on any 7-segment display, and the segment right here in the top is called A. And then you go clockwise direction. So you have B, C, D, E, F, and the middle one is G. Surely there is a decimal point which is a side. But the 7 segments, again, you start with the A in the top, and then you go clockwise direction, and you have B, C, D, E, F, and G in the middle. So far, so good. So now, that's exactly the appearance we have here. A, B, C, D, E, F, and G. So now, considering you're going to download this one, you're going to do yourselves a favor, and in order to understand how can you display the numbers 0, 1, 2, 3, and so on up to 9, you should know what segments you should light up. So in order to get, let's leave the 0 to the end. In order to get the 1, as you can see, you have to light up the B and the C. Write it down. B and C. In order to have the number 2, the LEDs you have to energize are going to be A, B, not the C, the D, the E, not the F, but the G. So I write it here. This is B and C. This is A, B, D, E, and G. For the 3 is A, B, C, D, and G. A, B, C, D, and G. For 4, not A, but the B, the C, the F, and the G. So B, C, F, and G. For the 5, is A, not the B, but the C, the D, the F, and the G. So A, C, D, F, and G. For the 6 is A, not the B, but C, D, E, F, and G. A, C, D, E, F, and G. 7, A, B, and C. A, B, and C. 8, all the segments. So A, B, C, D, E, F, G. A, B, C, D, E, F, and G. All of them. For 9, A, B, C, not the D, not the E, but the F and the G. So A, B, C, F, G. And finally 0, I left it aside, all segments excepting for G. A, B, C, D, E, and F. A, B, C, D, E, and F. So that's important to understand. What segment should I energize in order to form each decimal number from 0 to 9? So you're going to have this one to download, and then you're going to do the same I did here to know exactly what segments to put on. Let's go further. Now, this is how the segments are going to be lit. But here is the physical object. So what's the relationship now between the physical object and this drawing? In other words, I want to energize the segments, but if I take a look here on this display, I turn it on the other side and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terminals. So what's going on? This one has 10 terminals, but here I have 8 diodes I have to light up. So let's find out how it is organized. If we arrange these LEDs in a row, like here you have the LED representing the segment A, the B, the C, D, E, F, G, and this is the DP, the decimal point. But if you count, there are 8 diodes and each of them has 2 terminals. So 8 times 2 terminals, you are expecting a package having 16 pins. However, I'm reminding you this one only has 10 pins, it doesn't have 16. Why is this? Because the way the diodes are organized inside that package, because that package is like an integrated circuit, there are some wires already drawn inside the package. There are 2 ways to organize. One way is the manufacturer decided to relate all these terminals together, you see, all these together. What kind of terminals are related together here? If you take a look, here is the anode, here is the cathode. So all the anodes are related together. For that reason, this kind of arrangement is going to be called common anode. Why? Because all the anodes were related together. So then, if it is the case, and you put all the anodes together, this one, somehow, it has to go to the positive voltage, because the anode is the positive terminal of the diode. So you have to give a negative on the cathodes. Now remember, you won't leave any LED energized without a resistor. So here you are going to connect some resistors. And to close the loop to the power supply, from each resistor, you have to provide a kind of negative voltage depending what segment you want to light up. So for instance, if I pick up my paper sheet and I want to light up the number 7, I have to light up the diodes A, B, and C. So where is A? It's right here. So this one, the B and the C, I'm going to relate all these ones to the ground. So this way I close the loop because I'm going to have positive, anode, cathode, resistor, limiting resistor, and the ground. So that's how I'm going to get the segments going on. Next thing, the same manufacturers, for practical purposes, they have a second kind of arrangement. So in the top, they related all the anodes together. But there is another version of the same. This one here, it's exactly that kind of arrangement. But there is another one identical to it, is looking exactly the same, where the terminals related together were these ones. So the anode is here, the cathode is here. All the cathodes were related together. So if this is the case, that kind of digit is going to be called common cathode. Why? Because all the cathodes were related together. So in this way, the cathodes are going to go to the ground. All. So then, in order to make the loop and to have the power supply involved right here, you have to connect the resistors on the other side, the limiting resistors. And if you want, let's say, to put the number 1 on, you need the segments B and C. B is here, C is here, so you relate them together, and then you connect them to the positive voltage. So, common anode, common cathode. Let's pick up the one in the top. We do one at a time. So for the common anode arrangement, now let's count how many terminals we need. There are 1, 2, 3, 4, 5, 6, 7, 8 diodes. So we need 1, 2, 3, 4, 5, 6, 7, 8 cathodes to manage. And here we need the common anode. So 8 plus 1, 8 cathodes plus 1, the common anode, is making 9. 9 pins or terminals. But if I'm taking a look at this one here, this one has 10, it does not have 9. Why is this? It's because there are 2 rows of terminals. If you keep the digit aligned with the decimal point on the bottom right, 5 terminals in the top, in the bottom, and 5 in the top. So for some other practical reasons for the designers to have access to the common terminal on both sides, there is one common present here in the bottom. So one of the 5 terminals in the bottom is going to be the common anode, and is going to be a second common anode in the top. And obviously, the 2 pins are going to be related inside the package through a wire. So the designers making the printed circuit boards, they will have access here in the bottom and in the top for the same anode. This is why, instead of having 9 pins, it has 10 pins or terminals, because the anode, the common anode, is repeated in the top and in the bottom. And this is going to help us to clarify what anode, or if you want, what terminal goes to what LED. So then, in order to clarify this, we're going to make a drawing together. Here is going to be our package, like that. This is the shape of the package, and we have 1, 2, 3, 4, 5 terminals in the bottom, and 1, 2, 3, 4, 5 terminals in the top. Again, with the decimal point on the bottom right, all manufacturers, they make the terminals 1 is here, 2, 3, 4, 5, and you go counterclockwise, 6, 7, 8, 9, and 10. So let's suppose you never saw one of these. You never played with it. I'm going to write it one by one, the steps. How can we identify ourselves without even knowing what is the data sheet of the whole package? What segment goes to what pin? Because here we have, if you want, here we have the segment A, here is B, this is C, D, E, F, and G. So we want to identify, for the number 1, when I need B and C, on what terminals should I connect my resistors then? And take a look. I told you before that the common is somewhere present here and also there. So between the two commons is going to be something like 0 ohm resistance. So the step number 1, identify the two common anode pins. How do I do that? I put my DMM, the digital multimeter, on Ohm-meter. So I put it on the Ohm-meter. And take a look, what's the procedure. I put my multimeter on Ohm-meter. And then I pick up 2 wires. For me, it's much easier to play it on a breadboard. I connect one to the pin number 1. And then I'm going to check the pin number 1 versus all the other pins of the package to find out if, by chance, let's give it a sound. You see? So now when I make a short, it's going to emit a sound. So then I have one wire on the pin 1 and I connect the second one to the pin 2. I can't hear any sound, it's overload. So if one common is here, the second common is surely not here on the second pin. I go on the third. No common. On the fourth, no common. On the fifth, no common. Now I pass on the other side. On 6, on 7, on 8, 9, and 10. So there was no connection between the pin 1 and any other pins around the package. In other words, I just found that the pin number 1 surely is not a common. So then I go further and I move it on the pin 2. And I check again the other pins versus this one. I check this one, pin number 3, number 4, number 5, 6, 7, 8, 9, and 10. So surely the pin number 2 is not a common because it does not show 0 ohms with respect of any other terminal around the package. Now I move it on the pin 3. You see the pattern here. Now I go pin 4. I don't need to go on the pin 2 because pins 2 and 3 I checked already. Pin 4, pin 5, pin 6, pin 7, pin 8. Hey, take a look. It's a low value in ohms, is not overload anymore, and I can hear the sound. So I just identified pins 3 and 8 are both representing the common. So here is a common, and here is a common. this one. But because I never saw that package before, I have no idea. Is my digit a common anode or a common cathode? Because remember, there are two options. Either all the anodes are together or all the cathodes are together, and I don't know which. This is going to be the step number 2. So, step number 2. Find out what kind of display it is. Common anode or common cathode. How do we do that? This time we put the digital multimeter on diode measurement. On diode measurement, okay? And take a look what we do. It's now on ohms. Right here is on diodes. So I can see the little symbol for a diode right here. And now I have one leg of the multimeter. I have it already on the common. So I connect the other one on any other pin excepting for pin 8, because pin 8 again is the same common. I connect versus any other pin, like here. I can't see any light. But remember, the diode can be connected two ways. The diode can be connected like that or like that, because the diode is going to conduct only one direction. So maybe that's not the direction I need. So what I do, I reverse the two pins. I put this one here and that one here. And if I do, take a look. I can barely see it, but I can see it here. I can see the light. So I can see the light. And if I put it opposite way, this one in the middle, and the other one here, I can't see the light. So I keep one on the common and the other one on the light. And then take a look what I know. The pin 3, where I have this green wire here, the pin 3 where I have this green wire here is connected to the red of my meter. So the red is associated with the positive. So the common is actually now, when I see the light on, is a common anode, because the anode is the positive terminal of a diode. So what I know, this kind of digit I just identified now, answer. My digit is a common anode type. So I had the step number 1. I identified the two terminals representing the common. And then step number 2, I found out that my display is a common anode type. And I have now last step number 3. The pin numbers for the 8 diodes. What are my 8 diodes? A, B, C, D, E, F, G, and decimal point. So I go for this one now. For this one, I'm going to use now a power supply because it's better visible. I have my power supply on 5 volts, and I pick up here 2 wires. I just need one resistor. One resistor, I have here 8 resistors in a row. I pick up any, and with this very short wire, I'm going to connect the pin number 8 to the positive, because I know this is a common anode. So the anode is going to go to the positive. And then I'm going to apply from the ground here through the resistors. 1 resistors I need. I'm going to apply to each pin energy one by one, and then I'm going to see what pin is assigned to what segment. So let's take a look. Pin number 1. Oh, when I touch the pin number 1, this LED goes up. What is this segment? If you take a look, is the segment E. So I know now that for my drawing here is the pin number 1. This is representing, or is connected to the LED representing the segment E. I go further. I connect it on the B. I connect it, on the next pin, which is number 2. Pin number 2 is connected on the bottom segment here, which is D. So take a look how it's going on. Pin number 1 is connected to the segment E. Pin number 2 to the segment D. I go over the common on the pin 4. I don't assume anything. I just measure. Take a look. On the pin 4, that segment here is C. And by the way, I'm going to complete the information. This is common anode, because now I know. Common anode. So here is the C. I move it on the pin 5. Oh, on the pin 5 is my decimal point, is DP. DP stands for decimal point. This one. Okay, DP. So the decimal point is connected on pin 5. I go on the pin 6. Oh, on the pin 6, what do I get? On the pin 6, I have the segment B. The segment B is this one here. See? Next. On the pin 7, I have the segment A. I pass over the pin 8 because pin 8 is the common. I go on 9. Oh, 9 is the F. Why the F? Because this segment here, which is F. And last one, no other choice, is G. So you see, it's like I never saw that package before. And now I identified here what segment is connected to what terminal of the whole package. And now I identified the whole package. I didn't even need the paper sheet representing the documentation of this package. However, I'm going to give you the documentation for this one because it's ready. So we take a look. I have it right here. So for the version where the pin 3 was connected to the common anode and the pin 8 to the common anode too, both of them are representing the common anode. Now we take a look and we compare the paper sheet coming from the manufacturer, this one, versus the one we just completed together. Pin 1, segment E. Pin 1, segment E, it doesn't matter, they use the lowercase. The letters are still the same. Pin 2, segment D. Pin 4, segment C. Pin 5, the decimal point. Pin 6, segment B. Pin 7, or terminal 7, segment A. Terminal 9, F, and terminal 10, G. So this is from the manufacturer. But again, the method I just gave you in 3 steps allows you to identify any such digit regardless the manufacturer, okay? Now, let's go further. We're going to do the same on that package here, where we start from scratch. Remember, if you want, I'm going to put it here. I use another package, this one. So, step number 1, I want to identify the two commons. And because I suspect that the organization of the packages is pretty similar because they look identical, I'm going to put this one on ohms again, step number 1. And I go directly to see if the pins 3 and 8 are together, because I identified it already on the other one. Okay, so let me see. Yes, pin 3 and 8 are connected together, exactly like for the other one. Now, step number 2. What kind of display it is? Is this a common anode like this one, or is the common cathode? So then, I use my multimeter on diodes. Remember? If I touch the two terminals, I'm going to hear the sound. Okay, because it's a short circuit. So then, I connect randomly from the common. I pick up one of the wires, I don't care which, and I connect the other one on any other pin. Sorry, I can't see any light, I can't see anything, even if I put the light off. Then I try opposite way. This one here and that one here. I can see some light already. So this is the good arrangement for that kind of digit. Okay? So now I know this is my common, and this is going to the black of the meter. So the black of the meter represents what? It represents the negative. The negative is associated on a diode to the cathode. So this kind of digit is a common cathode arrangement. This is why right here I have a second drawing, and this is when the digit is organized with the common cathode, and 8 is going to be common cathode. See? Common cathode. And guess what? The segments are going to go on the same pins as the other one. Just the common is not the same. Let's check it if it is true. I'm going to use the same power supply as before. Okay, so the same power supply as before. This time the common, which is right here, is a common cathode, so it's going to go to the blue line, which is the ground. So then I disconnect my ohm-meter. I don't need it anymore, this one, okay? And instead I'm going to connect my power supply. As usual, I just need a resistor. And now I'm checking out. A should be on 7. I can see it here is 7. And the reason I make that connection is because I want you to see the amperage coming on the segments to show you that all the diodes are identical. So it's around 7 milliamps. If I move it here, B should be on 6. I just move it one pin. B should be on 6. 6 is representing the B. 4 should represent the C. I just connect it right here. This is the C. The D is the pin number, take a look, is the pin number 2. E is the pin number 1, right here, take a look, E. F is the pin number 9. is adjacent to the pin 8 representing the common. And finally 10 is the G. And do not forget, the decimal point is the pin number 5. So the arrangement of the pins identical to the other one, but this is a common cathode arrangement. It's not a common anode, it's a common cathode, see? So that's how you can identify clearly without even having the paper sheet from the manufacturer, which is which. And by doing this, remember, what did we need? We need this one coming from the manufacturer, we could check ourselves. We need this one to understand the two possible ways the manufacturers are making the links inside the package, either linking all anodes together or all cathodes together. And finally, we need this one to show you, or to show us, what segments should we put on if we want to display the numbers 0, 1, 2, 3, and so on. So you're going to find 1, 2, 3 paper sheets in the folder about the Civic number. And next time, we're going to make our project. Thank you very much. See you next time.